So now we're going to look at number 21, 22, and a few others. With number 21, I told you to simplify a to the 6th, b to the 10th, a to the 4th, b to the 4th, and a to the power negative 2. What you need to understand with this problem is the laws of indices. One of the laws says that whenever you have a certain thing, so for example 2 to the power 4, so a to the power 4 times a to the power 3, so times 2 to the power 3, is the same thing as a to the power 4 plus 3, which is a to the power 7th. They have the same base. And so 2 to the power 4, or 2 to the 4th power times 2 to the 3rd power is the same thing as 2 to the 4th power plus 3. And that gives us 2 to the 7th power. That's how you do problems like this. So using this law of being able to add things because they have the same root, or the same base, a to the 6th and a to the 4th, we can bring them together. So another way of rewriting this is a to the 6th, a to the 4th, a to the power negative 2, b, and then b to the 10th, and then b to the 4th. Now all that we need to do is to add the exponents so that it becomes a to the power 6 plus 4, and then a plus, and then minus 2, and then b to the power. This is essentially b to the first power. Whenever you see b by itself, it's the same thing as b to the first power. And that's b to the first power, b to the 10th, b to the 4th. And all you need to do at this point is add those things. So a, and then this is 6 plus 4, 10. 10 plus minus 2. Whenever a plus and a minus meet in this kind of situation, actually in all situations like this, it becomes a minus. So it's 10 minus 2, which is a to the 8th power. And then b to the first power plus this 10. So 1 plus 10 plus 4 would be b to the 15th. That's all you need to do for number 21. With number 22, which was one of the most difficult from what I realized from questions that students asked, m to the power 2 plus a, and then we have a bracket here that says m to the power a, n, and then a 3a outside, and then m squared n 3a. We need to use, or we're going to use several of the laws of indices, or several things, certain principles here. The first thing I want you to do is to deal with the bracket and the exponent right there. So now you have m2 plus a. This inside would become ma times 3a. That exponent goes in to both of them separately. So it goes to m to the power a, and it also goes to n. So that it's ma times 3a, and essentially what happens is we still have divided by m squared n 3a. And so at this point, we have our n to the 3a. So when you look at this, you would realize that m to the power 2 plus a, ma times 3a, and then n 3a. What you need to do again is don't be afraid. Just look at what happens to the 3a. m 2 plus a and m 3a squared, because now it's m2 plus a, and then this other m is now m 3a squared, and then this is n 3a divided by m squared n 3a. Now, according to the laws of indices, I'm allowed to add the exponents of the m because they both have the same base. And so m2 plus a plus 3a squared, and then n 3a. That's the top. On the bottom it's m squared, and then n 3a. And so if we have this, what we need to remember now is that according to one of the laws of indices, I'm allowed to bring things from the bottom to the top. And the only way that I could do that is to bring in, or to take the, so now I'm bringing things to the top, and all I need to do is it becomes m2 plus a plus 3a squared minus 2, because the m's have the same base. So that could come up. And for the n, it's also going to come up, and it's going to be n 3a minus 3a. What this does, and of course this is a variation to the question in your paper. The question in your paper had 2a, but this is 3a, which makes it a little more interesting, because this shows you another law of indices. Now, m2 plus a plus 3a squared minus 2. The 2's can go away. They're like terms. 2 minus 2 is 0. So now we can rewrite it as ma to the power a plus 3a squared, and then the n is simply n to the power 0. And this just gives us m, and then a can be factored out, 1 plus 3a. You don't have to factor it out. And then n to the 0, that's what I was going to say. Anything to the power 0 is 1. And so that becomes a 1 essentially. So our final answer is simply m to the power a into 1 plus 3a times 1. But you just leave it as m. We'll just leave it as m to the power 3a squared. That's all you do with this problem. And let me take away that line. That's all you do. That's how you handle it.
Eric, thanks. Mrs. Joseph is leaving.